Hello and welcome to Amaze Me, BBC's Earth short films, which tell you about amazing new discoveries in natural sciences. And it's the ones that really sparkle that we're interested in, the ones that you're going to want to know and then want to tell your friends and family. And today we've got a cracker for you.
Now, there is a lot of threats in the natural environment. So today we're going to be talking about the ways in which animals are able to defend themselves and also attack one another. We're going to be talking about the differences between poison and venom.
Yeah.
What is the difference? How do you distinguish?
Well, first of all,
between
people
the two?
love those sorts of animals, don't they?
Yeah, we like a
When I was a
poison.
kid, I loved venomous snakes.
Yeah, toxins and things.
Yeah, I mean, those neurotoxins, the cardiotoxins, I used to be into all of that sort of stuff. Got bitten by a couple of venomous snakes, in the finger, puff had
Did it hurt?
It's very hurt indeed.
I bet it did.
Indeed it did. Yeah, so I think we're drawn to those sorts of animals because of the mystique, but we frequently get it mixed up between venom and poison.
Yeah. But there is a very distinct difference. And it's typically about how the toxins are distributed. So let's have a little look at a couple of animal examples. Let's look at the venomous ones first. This is a Mozambique spitting cobra.
What a photo.
Look at that. Look at the distance on that spit there. That's incredible, isn't it? What an amazing animal.
Squirting that venom out of its fangs, hopefully into the eyes of an attacker.
I wouldn't like to be above it, would you?
Using the fangs to inject it into a victim if it's attacking it.
Yeah, exactly. So let's look at the second animal. This is the Cape burrowing scorpion.
Sting in the tail.
Also very ferocious kind of animal, isn't it?
Yeah.
It's not something that you would want to
tread
on. Yeah, and I've been stung by a scorpion on the foot. I was. Yeah, it does hurt. It really does hurt. Obviously, there's different toxins. There's different variations of how much it can hurt. But the difference there, the reason why they're venomous is because it's an active defense. So these are animals which have fangs. They're animals which have stings. And they go about injecting or putting in toxins in that way by puncturing the skin and putting the toxin directly into the body of the attacker.
Yeah.
It's an active attack, exactly that. So poisonous animals, what's going on there? Let's have a look at a poisonous frog. Now this is a dying poison frog. It is a beautiful thing, isn't it?
That is exquisite, isn't it?
It is a stunning amphibian. Look at the colours of it.
I know.
It is stunning.
I'm in love. That is amazing.
Beautiful. And this is a poisonous example. So this frog has toxins within its skin. And this is a defense mechanism. It's a lot more passive. It's a passive way of passing on toxins to something that might want to eat you. So when you have toxins in your skin, if something comes to peck at you, if it comes to grab you, or you rub against something that might be a threat, then you're kind of passively telling them off or giving them a warning or potentially causing fatal injury depending on the amount of toxins that's given. So it's how the toxin is distributed that's the difference between venom and poison.
And here's the thing for you. Yeah. When I was 14 years old, I was bitten by the UK's only venomous mammal.
Are you?
Any ideas? UK's venomous mammal. I was on a riverbank. I was catching these animals alive, of course. I was studying them. I picked one up. And it was getting out of the bag, so I stopped it from getting out of the bag, and it bit me in the finger. And I did get a small reaction to it, which has been reported in other people too. It was the water shrew, which has venomous saliva, which when it bites, it injects into its prey to stun it and to paralyze it. But I've got to say that venomous mammals are very, very rare across the world. So you've got the shrews, water shrew, and a few associated species. You've got a thing in the Caribbean called the Solodon, which is a shrew-like animal, but in a completely different family. You've got things like vampire bats, of course, which also have a venom aside from sucking blood, but they're quite rare, not many more.
Well, you've got lorises, for example, and they've got the kind of toxin gland under their armpits, and they're able to harvest the venom in their teeth, which is pretty impressive. And also duck-billed platypus, because the males, they've got the claw, haven't they?
Yeah.
When they're protecting females from other males.
Exactly that. So only a handful of species. But our amazing news today is that some scientists have discovered yet another animal which uses toxins to repel potential attackers. Another poisonous mammal. And it is the African crested rat. Have a look at this.
Oh, it's very sweet. Look how cute it is.
Well, it is quite an attractive animal.
Yeah.
I tell you what it reminds me of, though,
Go
with its black and white pelage there. It looks a bit like a skunk, or the African equivalent, which is a zorilla.
Yeah, I think it looks a bit like a porcupine.
It does, yeah.
But there's no it's not happened by chance, that, has it? It's done that on purpose. It's evolved to look like that, because often animals which are seemingly harmless will evolve to look like animals which are seemingly not so harmless. And it's an example of Batesian mimicry. So they're mimicking animals that could do a predator or an attacker some kind of damage.
One, now we know,
can
do
but it
some
can.
harm.
It's got a double-edged sword. I like it.
I love that.
Yeah.
I love that. So this rat lives in Eastern Africa. It's a relatively common species. Scientists thought it was solitary, and they found that it was in fact poisonous. How does it become poisonous? It needs to get that poison from somewhere, and it gets it by chewing the poison arrow tree. It chews the bark of this tree. Now, the tree is known by local people to be poisonous, and for a long time they've harvested that poison, which they've tipped arrows with themselves so that they can use that poison when they're hunting to incapacitate the things that they're hunting. So they would take an arrow, somewhat like this one. This is a replica of an arrow that was used at the Battle of Agincourt, 1415. I'm not getting too much detail into that, but what they would do is then wipe the toxin onto the tip of the arrow like this, so that when they fire it into the animals that they're hunting, it would incapacitate them more quickly. So humans would use that poison, but it turns out that the rat has been using it for probably a lot longer. It chews it, and then it rubs its saliva into its side. And we've got a little clip of this here. It's self-anointing. And you may have heard of self-anointing before, because European hedgehogs self-anoint. They will lick their spines, and we've never been entirely sure why they're doing it. But here, look, you can see the crested rat, and it's rubbing it in to hairs on the side of its body. But they are no ordinary hairs. On this part of its body, the hairs have special adaptations which allow them to take up the poison. And here you can see those hairs under a microscope, and they've got all of these little pits in them.
Amazing, isn't it?
Yeah.
So assuming that is where the toxins sit in those pits, ready to be rubbed up against some kind of attacker or intruder.
And exactly that. And then if anything comes to attack the rat, maybe it's biting it, maybe it's a leopard,
a jackal,
or something smaller like a genet, perhaps, attacking the rat, it would ingest the poison from the fur on its side, and therefore be affected by it, no doubt causing numbness, perhaps distaste, maybe even pain in its mouth. And therefore, the crested rat would survive the encounter.
It's pretty amazing. These hairs are pretty special. They do something called piloerection, where they lift the hairs up, making themselves look even bigger, looking more scary to any oncoming threat. So maybe the way they lift their hairs and the anointment themselves with the toxin is pretty good, isn't it? It's a good defense they've got going on.
It is. And when the scientists started looking at these rats in more detail, they actually realized that they weren't solitary animals at all. They were not moving around in groups in a highly social way, but they seemed to know one another. When they were looking at them in captivity, it was clear that they formed those sorts of partnerships. So what about that?
Oh, it's very sweet, aren't they?
Well, you say that, but you wouldn't want to bite one.
I wouldn't want to bite. I don't particularly want to bite any kind of rat or animal.
No, I haven't seen you biting a crested rat for
some
time.
It's not something I make a habit of, if I'm honest. But they are sweet. I wouldn't mind just snuggling up with one. They look quite cute, but maybe not if they're covered in toxin.
I know. No. That's it, isn't it, really? Yeah. And I love the fact that there were so few of these venomous and poisonous mammals out there, but we've added another one to the list. Top work to all of the scientists involved in that study. If you've heard of any other discoveries yourself that you think we might be interested in and would amaze other people, we would love to hear from you.
Yeah, pretty amazing stuff. It goes to show that we've got so much left to learn. Perhaps all the other mammals out there that could be anointing themselves in toxins, could be doing it massively. And
listen,
we don't know about
we were about to finish, but I've got to squeeze some last thing in.
Go on.
It's not about Agincourt or Crécy or Poitiers, those other battles of that period. It's the fact we've also found out that there were some poisonous birds. Yes, in New Guinea. Yes, things called pituis, and they actually get the toxins from beetles that they eat, and then they preen it onto their feathers, and we think it's to stop snakes eating them.
Oh, it's cool, isn't it?
We'll have to get into more detail with that some other time. But until then, goodbye.
Bye.